Hello, Unit 4, Lesson 4, exploring the properties of exponential functions. Let's get right into it. Exponential function, a function of the form y equals b to the power x, base to the power exponent. So we're going to quickly look at two functions here, but first we are going to make a table. And the functions we're going to look at, y equals, sorry, change the color here. Y equals 2 to the power x, and then we're going to look at y equals half to the power x. And for exponentials, we're going to use -2, -1, -0.5, so half, 0, and then we'll do the same going up. Okay, and that'll make sense in a minute. Okay, so if we plug in our x values into the y equals 2 to the power x equation, 2 to the power -2, remember the negative gives us a fraction, and 2 squared is 4, so this is actually 1 over 4. Then again, the negative exponent flips it up, so we have 1 over 2. And then when it's -0.5, you get 0.707. Okay, the 0 value, anything to the power of 0, you get an answer of 1. 2 to the power 0.5 or 1/2 is the square root of 2. So we get 1.414. 2, and then 2 squared is 4. Okay, so the half to the power x. Half to the power -2 is 4, right? The reciprocal from the negative changes it into a whole number. Half to the power -1 is 2. Then we have 1.414, 1. So it's exactly the opposite of the 2 to the power x. Okay, what we need to know here are some key points. These three right here, so when x is -1, 0, and +1, are called the key points of exponentials. Okay, if we're to graph this, so there's, remember for exponents, there are asymptotes. This one, there is no vertical translation, so the asymptote is just at 0, the y asymptote. And if we start graphing this, so when x was -2, we had a quarter, then a half, okay? This moves up and to the right as an exponential. This is called exponential growth. And the other one is just simply backwards, half, quarter, 2, and 4. So this is called exponential decay. And you can see our key points. Okay, the properties of these. So the first one, y equals 2 to the power x. The domain, pretty easy, just like with quadratics, XER. No matter what x value you put in here, we will get an answer. But the range, YER has a limitation because it is always larger than 0. Okay, the zeros, it never touches, it's an asymptote, never touches the x-axis, so there aren't any. There's one y-intercept, and that happens at 0, 1. And again, the asymptote y cannot equal 0. And then for the exponential decay, similarly, the domain and range are the exact same. Y must be greater than 0. There are no x-intercepts. The y-intercept is 0, 1, and the asymptote cannot equal 0. So they are the exact same. They're just moving in different directions. The transform version of an exponential function is y equals AB, and the exponent is kx minus d, and plus c. Okay, so remember this from a couple units ago. We can use this information with the mapping rule. Okay, so we'll just rewrite out the mapping rule up here so we don't forget. And that is x and y becomes 1 over k times x plus d, and a times y plus c. Okay, the parameters do the same thing as they did before for the mapping rule. Sketch a graph of fx equals -2, base 3 to the power x minus 4, and then a plus 2 for the c value. Okay, so we have a base of 3, but we have an a value of 2, or -2 if you want to include the reflection. We have a k value, so nothing in front of the x, that represents 1. A d value, remember you do the opposite of the bracket, so it'd be +4. And my purple's gone, but a c value of +2. Okay, so again, a equals -2, k equals 1, d equals 4, and c equals 2. So the first thing before we do the mapping rule, we should understand that our c value is actually the asymptote. Okay, so our c value was +2, so we have an asymptote at +2. Okay, so that means our function will approach that line but never actually touch. Okay, when we do our mapping, so we have -1 and 1/3 from, sorry, that should be, oh, right. So up here when we had 2 to the power x, -1 was 1/2, and our x value of 1 gave us +2, but now we're using a base 3. So it'll be -1, 1/3. It'll still be 0, 1, but it'll be 1 and 3. Those are the key points that we're going to worry about. So using our mapping rule, we have 1 over 1 times -1 plus 4, and we have -2 times 1/3 plus 2. And that is going to give us the point 3 4/3. Okay, 1 over 1 times 0 plus 4, and we have -2 times 1 plus 2, and that will give us a point of 4, 0. And finally, our third key point, we have 1 over 1 times 1 plus 4, and -2 times 3 plus 2, which gives us 5, -4. Okay, so if we plot those on the graph, we have 3 4/3, 4 and 0, and 5, -4. Okay, so you can see because of the reflection at the start of your A value, it is going down and to the right. Good. If we look at a table of values, we can tell a function is exponential by looking at the finite differences. So if we remember linear, we had first differences. Quadratic, we had second differences. Now we have finite differences. And to do that, we are going to first look at the first differences. So 3 to 5 goes up by 2, 5 to 4, or 5 to 9 is up by 4, by 8, by 16, 32, 64. Okay, so that gives us our first differences. And then from there, we're going to take the second value divided by the first value. 8 divided by 4, 16 divided by 8, 32 over 16, and 64 over 32. And you'll notice that each of these have the same value. So we're getting the same ratio of first differences. Okay, we move on describing the transformations and sketch the graph. Well, first things first, I'm just going to throw out the original parent function. Okay, now we're going to work with this. So we have, well, actually there's one thing we need to do first because the k value is with the right beside the x. So we need to actually change this. Do it in black so we can write it out. So we actually have 4. We factor out the k value. Okay, so this is what we're working with. There is no a value. The base is 4. We have a k value of -2, d value of 2, and a c value of 3. Okay, so, sorry, green. A equals 1. That's no change. K is -2. That's the horizontal compression of a half. It's also a reflection of the y-axis. The d value is -2. And that's a horizontal translation left of 2. And the c value is 3. That's a vertical translation up 3. Okay, so right away we know that this is our asymptote. So right at +3 we can draw that line. Okay, so our key points, because it's a base 4, we're going to have 1 1/4. Sorry, -1 1/4, 0 1, and 1 4. I'm not going to write out the whole mapping rule, but we can just work with it. So it's 1/k to begin. Our k value is -2 times x, so -2 times -1 is 2, plus our d value, which is -2. Sorry, we had 1/2 is -1/2 times -1 is half. Half minus 2 is -3/2. And we will get 13/4. Okay, 0 1 will become -2 and 4. And 1 4 will become -5/2 and 7. Okay, I know I'm skipping that, but this is a pretty dull lesson, so I'm just trying to get through it here, and we've looked at the mapping process before. So -1/2 up 3 1/4. -2 is up 4, and -2.5 up 7. So we have a line that looks like this. Good. So again, as we mentioned before, growth we did with blue. Moves up and to the right, and decay moves down and to the right. Okay, fun lesson.